All right, good morning. Yeah, all right. Morning to the second day of Ignite 2018. My name is Bob Ward. I'm a principal architect at Microsoft. Been around for a few releases of this release of SQL Server, been doing it for a while. So excited to be here this morning.
Good morning, everyone. My name is Amit Banerjee. I work as the lead program manager for the on-premise database engine for SQL Server on Windows and Linux. Thank you for being here. For the next 75 minutes, we'll actually take you through a journey of what SQL Server looks like, what we announced yesterday, and what we have on our roadmap.
Well, I want to congratulate all of you. You're part of a special bunch. Not only do you all fit tight in here, but you've got this unique aspect to you that we all share together. I was building my deck for Ignite. I was sharing with my lovely wife, Ginger. She was looking at it. She looked it over, and she said, "Do people actually like this stuff?" I said, "Not only do they like this stuff, but they actually pay a lot of money." And she walked away and she said, "There is something wrong with all of you." So, hey, this is unlike any roadmap session you're probably going to see. It's not going to be just a deck with some timelines. It's actually going to be a coverage of what is in SQL Server 2019 preview and stuff in action. We're actually going to show you how these things work. But at the end, we will talk a little bit about where we're headed. Now, a couple of homework items for you. Number one, the deck will be available on the Ignite site, like you would see other decks available. And many of the demos we're going to show you, because we are going to do demos here, are available on my GitHub site. Just search for GitHub Bob SQL, and you can find them. We want to pack it in, though. We want to give you as much stuff as you can to learn about SQL 19. So in order to do that, we are going to leave some time at the very end for a few questions, but I don't want anybody to walk away with a question unanswered. So this week, we have like a dozen sessions after today throughout the week on SQL Server. We have like 6 theater sessions going on. We have workshops going on, and we'll be at the booth. I know myself, I'll be at the booth all day tomorrow. Worst case scenario, if you don't get your question answered, email me directly, bobward@microsoft.com, amitbond@microsoft.com. So we want your questions answered. Come find us. We will stay also afterwards if you don't get your question answered outside to address your questions. Let's dive in, though, and talk about SQL Server 2019 and what this release is about, and the gamut and the capabilities we're providing. You may have seen the announcement yesterday. We kind of shook the industry a little bit by announcing that we are providing new capabilities with Apache Spark and HDFS included with SQL Server. This also includes new functionalities for Polybase, and Amit's going to talk and dive into that scenario a little bit for you in a minute. But if you think about what you see on the screen here, and the next section left of that, to right of that, is about our platform of choice, something we expanded on and we announced last year here at Ignite, in 2017 release, the capabilities of SQL Server on Linux and Docker containers, and we continue to enhance those capabilities. And we'll talk a little bit about that in this session as well. We want to make you fast for your performance for SQL Server, and we prove that with our benchmarks. But you also want to keep you fast. So you see this term intelligent query processing sitting on here. That is the functionality we're talking about. We believe in something called the intelligent database. We want to bake in functionality to keep you fast and give you the diagnostics just in time when you need it. And we have proven we're the most secure platform in the industry, but we also have functionality and capabilities, and so we've enhanced those in SQL 19, things like always encrypted with enclaves. And then finally, we continue to provide BI capabilities through Power BI Report Server and reporting services to get data across all your assets. If you look at the bottom of the slide here, this is about in-memory workloads for your capabilities, like column store and in-memory OLTP technologies. We continue to enhance those, and we provide those as capabilities for you and your workloads. But here's what's interesting. We use them ourselves. You're going to find out when you look more about like this big data analytics cluster, we're going to use things like column store to help make performance great. So those are great tools and things that we can use in the product to make things better for you. And thinking about consistency, SQL Server now is everywhere. We're on Linux, we're on containers, we're SQL 19 in your private cloud, or even things like Azure Database Managed Instance. And we believe in a story of consistency, whether that be the T-SQL language, the surface area, the tools, or the development APIs and programs that you use. Now, a couple of comments, and I'll turn over to Amit to talk a little bit more about our new big data analytics technology. A couple of things I'm going to pre-answer for you because you're probably wondering. Why isn't SQL 2018? Why is it 19? Well, number one, we believe that we would like to produce SQL Server actually as fast as we possibly can, and we did that with 16 and 17, right? But we want to make sure it's a quality release and a release that provides unique value. And so in this particular time, we are going to release this as SQL 19. And we announced the preview today, yesterday, and we're talking about today. But then you're asking yourself, well, when is SQL 19 actually going to release? Well, the answer is we're committed to the name. So you will see the release of SQL Server sometime in 2019, and that's as much as we're going to commit it to. I'm just pre-answering the question for you today already. So with that said, let me turn it over to Amit to talk a little bit. Amit, we kind of shook this up a little bit yesterday, right? Spark and HDFS. I mean, talk us a little more about that.
Thank you, Bob. Yes, this was pretty much headlines on social media. I was watching my Twitter stream when we announced SQL Server 2019, public preview, and I saw words which I never thought I'd see while working at Microsoft. SQL Server, HDFS, Apache Spark in one sentence. And what we have here today is not just about what you can do with another data platform. It's all about what you can do with your data. The first thing that we announced with this preview is the ability for you to create a data virtualization layer, as Bob was talking about. And it's been a journey. If you look back in time, SQL Server 2016 announced something called Polybase. Polybase allowed you to make connections into your Hadoop data sources and pull data into SQL Server and combine that with the high-value relational data that you store in SQL Server. But we also know that that's not the only database in your environment. You've got a lot more databases, a lot more data platforms that reside in an enterprise data estate. It could be in a private data center. It could be in a cloud. So what if we needed to bring all of that together? That's the first scenario. The first scenario is bring all of your data together under a single data hub. And here's the kicker, without having to move data. If you did not have to move data, but you could still combine it, that's a pretty powerful scenario. That's the first pillar that we're going after with SQL Server 2019 public preview. The second thing was managing all of your data. If you have a relational data source, if you have a NoSQL data source and a Hadoop data source, managing permissions across all these three flavors is difficult. Now put in the different vendors that you have for all of these technologies, that becomes even more difficult. Now then put enterprise security governance in there, you probably have a headache. You need a lot of coffee before you head out to do the data governance, the security modeling on all of this. But if there was one single data hub where you could pull all of these data, apply the security policies, but still give your business users the ability to access that data securely, that gets you pretty excited. That's what we saw on Twitter yesterday. And once you have all of that data in a single place, stored in a secure fashion, the next thing is, what do I do with this data? All of this data combined together, it's really exciting. It can give me so many insights. It can tell me so many things. You can actually make your data talk. And for that, you need to have AI capabilities that you can use languages like R, Python, and run machine learning algorithms on top of your data. And that's what we'd allow you to do, all in one single platform called SQL Server 2019. And this management, the tooling for this is, again, one single place, which is Azure Data Studio, which we announced yesterday. And what you'll see throughout the day is you'll see multiple sessions talk about how you actually take charge of your data and make your data work for you. So these are the scenarios that I'll go throughout. I'll talk to you during my demo. First thing is we need to connect all of this data. You make a virtualized layer. But now whether your app is talking to an HDFS data source, is talking to a database like SQL Server, or even talking to a database which is not a SQL Server, or even if it's talking to a non-relational database, it doesn't really matter because your application is just talking to one interface. Because your business user does not really care where your data is stored. They care about what the data is telling them. The second piece is you're combining two very, very powerful languages in the industry today, Apache Spark and SQL. The combination of both of them under one single engine gives you the ability to do things which are limited only by your imagination. And as I said, all of this is managed through one tool called Azure Data Studio. Now, these are the different things which I talked about. And these are all in our big data cluster capability. But what's really key to understand is, what if you have a SQL Server instance today? What would happen if you upgraded it? if you upgraded your SQL Server instance to SQL Server 2019, you would still get the data virtualization layer without installing a big data cluster. And that gives you the ability to talk to ODBC data sources, non-relational data sources like NoSQL stores, like MongoDB, Cosmos DB. It gives you the ability to talk to other relational data stores which are not SQL Server like Oracle, Teradata, and your HDFS workloads that you have. So even without having a big data cluster, you can actually virtualize your entire data estate today with SQL Server 2019. Now when you have virtualized all of that and you're pulling the data, and the key point here being without ETL, you can actually go ahead and run Spark jobs on top of your data. Now let that sink in for a while. You can run Spark jobs from within SQL Server against your data to get insights. You can run SQL queries against a Hive table. Select star from hive.orders is not science fiction, it's reality. And to top it all, now you want to do machine learning on top of that data, you can actually do it through Spark. You can do it natively within SQL Server with the SQL Server machine learning services. It's your choice. The key being, it's your choice. Whatever you're comfortable with, you can pick, and your data starts talking to you. Now for the technical minds here, this is the architecture diagram. And don't focus too much on what each of these boxes represent, but I'll talk you through the scenario. So when you have a big data cluster in SQL Server, you would get a storage pool which would have, SQL Server itself would have an HDFS layer. So you would be actually able to take your data, insert it using T-SQL to SQL Server tables, or if you had data coming in the form of JSON, XML, CSV, and you wanted to dump it into a scalable shared storage like HDFS, you could do that. SQL Server would set that up for you, and SQL Server would manage that for you. You could query that directly from the SQL Server master instance, which you see at the top, using either direct queries to HDFS, or you could write select queries against that data. You could also take data from other sources and other relational sources like Oracle, SQL, and combine that data with your HDFS data source. Now, if you wanted to scale out across your data pools that you have over here, you could actually do scale-out querying. Polybase introduced this capability of scale-out groups, and that capability took a huge improvement, got a huge enhancement, and it's really pumped up right now where you can actually scale out across your data set, and you can query petabytes of information using one single line of code. Now, if you have a data source which is not sitting inside SQL Server's HDFS store, you can actually use a compute pool that I just talked about, and it can go out and query the data that's sitting outside, and you can choose to either bring it inside and cache it in SQL Server in a data mart, which is powered by a column store technology, and build a data warehouse on top of it, or you could make direct queries. It's up to you how you want to do the scenario, depending on your business SLAs. And the small card that you see, all of that data that's coming into your cluster, all that data can now sit inside one single cluster. The big rectangle that you see, it is managed by SQL Server, provisioned by SQL Server, which you can elastically scale out, scale back in, and you suddenly have a single installation which works like a private cloud and a private data center in a private data center that you have, and it does HDFS, it does non-relational, it does relational, uses languages like Spark and SQL, and supports capabilities using Java, SQL Server Machine Learning, and Spark ML. I'll let that sink in for a while. So what we're trying to say here is data is the new currency. We're not trying to give you another data platform which helps you build another database. It helps you build a unified data platform, and this currency is what will get your business to new places. For example, I'm standing here right now, and I have my cell phone in my pocket, which is talking to my home automation devices and even the Fitbit that I'm wearing on my hand. But all of these data together can tell me a lot of things. Is my home unlocked? Is my home not secure? Is someone at home? Is the temperature at the right comfortable level that I feel it should be? But I have different apps doing all of that, and I have different data sets that I'm talking to. What if you could bring all of those data sets under one single data hub? That would really change the experience. I could just write a single query to go say, hey, is my home at the right temperature? Is my home secure? Is my monitoring on? If I'm leaving home, just write this update query. But today, that's not true. You have to go through multiple apps, multiple data sources, multiple authentication schemes to get that scenario done. And now with this capability, you can bring all of that data together and just write one set of automation with one set of security protocols, with one administration pane, everything under one roof. And we're not saying move your data. Let your data be where it is. We're just giving you a pretty combined experience. So let's see what that looks like on a SQL Server instance. Let me switch over to my machine here.
7. Yeah, there you go.
And what you see on your screen right now is Azure Data Studio, which we launched yesterday. And it's connected to a single standalone instance of SQL Server. And this is the power of the data virtualization that I was talking about. This is talking to another database that exists in the industry called Oracle. And I'm actually going to enter a new order here. So for example, right now, Bob and I were having dinner a few days ago when we were watching the game between the Seahawks and the Cowboys. And
Yeah, that didn't really turn out too well for me, did it? No.
not only did it turn out well, he actually had to go for retail therapy. So I put an order in, go back to my home, I can see all the orders. Now what if my data warehousing standardization within my company was SQL Server? If I had to build a report on Power BI on top of this, and if I had to do it in SQL Server, what would you do today? You would have to pull all of that data into SQL Server, create a Power BI report, and every time a new order like this came in, you would have to run your ETL jobs. So now what I'm going to do is I'm going to create something called an external table. And what the external table does, and you see the script right behind you, I'll show you how that got created. I select an Oracle. I don't need a master key because I have one created. I'm going to give it a name, say test. Give it the name of my server, my database engine. Select a credential, which is already created. Click on next. And what you see over here is actually the Oracle schema. And it's actually going to let me pick each and every table that I want to virtualize inside SQL Server. So once I select these, it's going to go ahead and show me what tables I want to port over, and it's going to let me either generate a script or let me create it. In the interest of time, I'm just going to exit out of that and switch over to Data Studio. Always helps when you have it open. So let me go back to my Data Studio, and what I'll show you is I'll show you the script that's actually in there, which can create the external tables. So I'm going to go ahead and run my script. And what that is going to do for me is it's going to create my tables, and it's going to virtualize the data from Oracle without having to move it into my SQL Server instance. And I'll switch over to my view over here where I have a customer view. And you'll see over here that I'm actually connecting my data source to a SQL Server instance. It's not connecting to a Oracle instance. And this dashboard will have all the data in there. So now it's actually finished doing all of that.
So let me be clear.
Yeah.
You're actually taking your Power BI dashboard and pointing to SQL,
SQL,
which is actually directed to Oracle.
Right.
Through the external table.
So what this is actually doing is actually taking my SQL Server data, and it's actually letting me run a view, as you see here. Let me show you here. It's actually connecting to those external tables that's actually querying to Oracle. Good question. And what we'll do is we'll actually have some time for taking questions at the end so that we can get through the content that we have. So the difference between Link Server and this is your Polybase allows you to create a scale-out group where you can scale out your query, whether you're using a big data cluster or you're using a SQL Server instance. With Link Server, you were pretty much doing scale up. You could never do scale out. This allows you to go scale out across any other data source, and without having to pull the data into SQL Server, and even if you're pulling it in, you could cache it in SQL Server using data marts backed by a column store technology. So this is fundamentally different from what Link Servers offers you. So now I'm going to go ahead and create the views, and once these views are created, I will just go ahead and refresh it, and everything shows up. And you can see that Bob has been doing a lot of retail therapy.
No Seahawks jerseys, though. I'm not going to get that.
We're probably going to gift that to him next time he comes to Redmond.
Well, yeah.
So now you have the ability to actually run a data warehouse on top of SQL Server, and you can use technologies like data masking, column store indexes, transparent data encryption, and all the other capabilities that we have in SQL Server, which I will not detail into, but actually run a data warehouse without doing ETL. You actually did not move any data. It's querying directly from SQL Server, and the SQL Server is connecting to Oracle to fetch that data. Now, what if I wanted to move that schema over? That schema can be moved pretty easily using SQL Server Migration Assistant. That's something that comes with our migration suite. And that allows you to do two things. The first thing it allows you to do is convert your schema. The second thing it allows you to do is migrate your data. Again, in the interest of time, I've already converted my schema and generated a script, which I'll run right here. So what that does for me is it allows me to create the schema, and it creates the SQL Server tables for me. Now let me go ahead and connect to my instance. So now that I've connected to my instance, what you'll see in my Ignite demo database is I have the external tables right here, and I also have the SQL Server tables that I just created. And because I'm using views, I can go ahead and change those views to now point to the tables which are newly created. And what that does for me is it allows me to change the underlying infrastructure that my database is using for my reporting without having to change my application. Now, obviously, this is not going to have any data in it. And just to make sure that I'm actually doing a change, I'm going to run this report, and there's not an error. Obviously, there's no data because I've not migrated it. Now, let's go ahead and migrate that data from that database that we talked about right now. I'm going to select all these tables, click on Migrate, connect to the Oracle instance, connect to my SQL Server instance. And what this is doing is processing the data migration. It moves over the 4 tables. And again, in the interest of time, I create a smaller data set. So it migrated all of the rows. And now let's go see what the report looks like.
Nice.
I actually moved an application from my reporting environment without actually moving data. And when I needed to switch over to SQL Server and migrate that entire application completely, I again switched it without breaking any new functionality that I've built on top of SQL Server. So now you have a choice with SQL Server 2019. You can choose to run your SQL Server instance using Polybase as a virtualization data hub, and you can build new scenarios on top of SQL Server, even though your data is residing somewhere else. And when you're actually ready, you can migrate off with our migration tools that we have. And if you don't want to do that, that's absolutely fine. You still created a virtualized data hub, which is talking to your OLTP databases or any other data sources that is serving a different function within your company. But all of that is virtualized under one unified data platform that you've known for 25 years called SQL Server. Now let's switch back. Let me go ahead and talk about what this does for us. This actually takes a very big leap of faith where we are actually changing the industry here. Every vendor talks about, come to my database. What we're telling you is, if you're really happy with what you have, you can stay there. But if you want to build on top of it, here's a layer that allows you to build on top of it. If you want to scale that out and use any of the common data sources that you have today, or build on top of big data or SQL Server, you have the capability. And then when you see that this is the best database in the world and you decide to move over, you have the ability to use our migration tooling to actually move over without disrupting the new capability that you've built. Migrations are always tough because you keep building on top of what you have. Now we have just provided you the ability to build on top of what you already have, but still leveraging the new without disrupting the old. So now I'm going to ask Bob to talk about what he's seen over the years in SQL Server. And what's very interesting is he told you he's worked on a lot of releases, but this is quite a special year for Bob, isn't it?
It is. So this is actually the 25th anniversary of SQL Server on Windows NT. We're actually having a little celebration Thursday at the booth. And I'm actually celebrating my 25th year at Microsoft this year. Yeah. So I started on SQL Server OS2 1.1 with diskettes.
How many, quick question here. Sorry to stop you there, Bob.
Okay.
A quick show of hands of how many of you knew that version?
Okay, we need to have like a little therapy session afterwards. Yeah, the funny thing is that some people at my office now in Texas, I tell the story and they kind of walk away because they're younger than the actual release of SQL Server, the history. So it's a little bit interesting, but yeah. I've seen a lot over the years, that's for sure.
So Bob, why don't you tell us what's new in SQL Server 2019, apart from what we just talked about?
Sure, okay, absolutely. Yeah, so first of all, that I think is actually a pretty amazing technology. Now you have this unified data concept, and I don't know if you really soaked in what Amit was just showing you, but the ability to just kind of almost in a way incrementally migrate off an Oracle system onto SQL instead of just one big migration, use external tables, use views, use that technology, and then like we said, it's scalable, plus all our great other features that come with it. So one of the things I specialize in SQL Server is kind of what I call the meat and potatoes. I borrowed that term from my friend Connor Cunningham. And the meat and potatoes of SQL Server is performance, security, and availability. And the great thing about what Amit just talked about with big data clusters is that we're taking the power of all that technology and bringing it along in that area now with things like HDFS and Spark. And so if you do think, though, about the releases we've made in the last few years, SQL 16, SQL 17, and now SQL 19, our preview, we keep building on these stories. Whether it's SQL 16 adding query store as a technology, or whether it's always encrypted with enclaves or dynamic data masking, or enhancements we made to availability groups, we now have other enhancements in these areas in 19 that we're very proud of and want to talk to you about. One of the areas I kind of focus on in our company at Microsoft is performance. And I told you a little bit earlier that one of the things that I'm very, very keen on and what we do is not just make you fast, and our benchmarks kind of show those things, but keep you fast. So you may have heard this term called adaptive query processing that we launched with SQL 17 and something called automatic tuning. We've kind of rebranded that now with SQL 19 and call it intelligent query processing. In addition, we also want to add functionality that gives you what I would call query profiling diagnostics just in time. And we'll talk about, I'll show you a demo in a second like that, for that. And then finally, we want to take advantage of hardware innovations in the industry. So things like persistent memory, we want to enlighten the SQL Server engine to recognize that type of hardware and accelerate performance, I/O performance, by almost bypassing the I/O stack in the operating system to make queries faster. So, for example, our friend on our team, Argenis, this week will be speaking on that type of technology, so to look for his hardware optimization talk for SQL Server. So those are the three things together that we call this idea of an intelligent database. We want to bake, built into the SQL Server engine, not add-on, but built into the SQL Server engine, capabilities that give intelligence to the query processor, to the engine itself, to make you and keep you fast. Look at this tree right here. This represents the suite of intelligent query processing features. And the amazing thing about this suite, based on a combination of SQL 17 and 19, is that there's no changes required by you. The only thing you have to do is use the compatibility level of SQL Server. The only way to switch it on is use the latest compatibility level of the database. So for database compatibility 140 for SQL 17, you get what's in the area here that's not shaded. Adaptive joins, things of that nature. And the things that are bold adds to that story. So if you use database compatibility 150, you get additional technology. But I'm a big believer in demos. I like to show stuff off. So I'm going to show you some of this stuff in action. Can you hit 6 right there for me? OK, I've got SQL Server 2019 preview installed. And again, Bob SQL GitHub. I've got these demos. You can just try them yourself. And I'm going to kick off a workload. with a little fun tool called ostress. And as I kick this off, I like to use batch requests per second to show kind of throughput for workloads. And you can kind of see what this workload looks like. It's a little choppy. It's OK. It's gets some peaks here as far as speed goes, but it's a little choppy. Now, what this workload is running right here is this stored procedure. And this stored procedure is a little bit typical sometimes of what you might do. You might build a table variable, right, that matches a table in your database. You might insert data into this table variable and then run some sort of join from the table variable with other tables in the database. Well, table variables have had this interesting property for a while, and it's something called cardinality estimation that's fixed. So we always fix the cardinality estimation for a table variable at 1. Well, that doesn't work quite well when we process queries for you and compile queries with a cardinality estimate of 1 if you've got a lot of data in this table, which I am in this case. So this workload should finish. If I go back over here and look at the results, let me zoom in for you. It took about 33 seconds to run this workload. Now what I've got is the same exact workload, except I'm going to turn on database compatibility 150. In this case, I'm using the wide world importer sample, so it's pretty easy for you to set this up. So let me kick this off and run it. Now I'm going to go over and look at my batch requests per second. And you can kind of see that it's going to take off, and it's going to be a little bit actually better from an overall workload perspective, and it's going to finish a lot quicker. So by the time I show you this chart and look back, this is already done. So now I get a pretty good boost of performance. Instead of like 33 seconds, it's now in 13 seconds. So why was it any different? Just by changing compatibility level, what was different about what happened? Well, in Management Studio, what I'm going to do is I'm going to go in and look at the query store reports that are built into the product with this tool, and look at my top resource performing queries. And if I look at that, I'm going to notice very quickly right here, in this particular bar, I'm going to see to the right, there are 2 circles. The way Query Store works is it takes a look at the query that's the same, and if the plan has changed, it's going to show you a difference between those plans, which is what I see here. At the top, this is the one that took longer, and if I hover over this, I can see, for example, that the average duration of this was about 3.8 seconds for this particular workload. If I look at the bottom and click here, and I hover over this, I can see that the average duration for this workload was less than a second, like 160 milliseconds. So what's different about them? So if you click on the top one here and look at the plan, you're going to notice it does a clustered index scan of this table, and it uses something called execution, right here, let me show you this, called execution row mode, right? And it actually does an index seek to the actual user table. So it's using the table variable, and then notice here also that it's using a nested loop join. So effectively, we only think there's one row in the table. So why not would you just join these together by starting on the outer table being that one row, and then looping over the other table in this nested loop joins fashion? Well, that's not all that efficient. So if you look at the bottom query, though, and pick its plan, notice a couple things here about this. We still are going to scan the actual table variable, because what this functionality provided for intelligent query processing is a deferment of compiling and the queries that are going after this table variable. So what it allows us to do is make smart decisions, what we call downstream, into the query plan. So we're scanning the table variable, but notice a couple interesting properties here. Number one, the estimates are actually accurate this time. Instead of 1, we know the actual estimates from the table, and then notice this, we're using batch mode. This is showing a combination of technology now. Before, with adaptive query processing, batch mode processing was only allowed for column store tables. Now batch mode processing, where we process rows and operators in batches, can be done on row store tables, which is this example. So it's a combination of the technologies together. Second of all, we were able to make a smarter decision to use a hash match join instead of this nested loops join, which is more efficient in this type of query. And then notice over here something called an adaptive join operator. So in this particular case, we actually combined 3 different technologies when we compiled this plan for this query together to give it a much faster execution run. Query Store is such insightful and gives you great insight by default when you turn it on. I see here this is query ID 4. I can go over and run a query against the Query Store views themselves, look at query ID 4, and notice here that we record the compatibility level of the query. So the difference here between the query was a new plan was generated with an increase in the compatibility level, and the average duration went way down. So a great example of, by changing the compatibility level, queries that you ran before against table variables just automatically get faster built in without any changes on your part, and Query Store gives you insight on why those changes actually occurred. So that's what's called deferred table variable compilation. It's built into the query processor, and it's part of the intelligent query processing suite that we've provided in SQL 19. Now, I got one other one to show you.
Let's see.
Yeah. So we talked about something about giving you insight just in time. There's this feature that we released called lightweight query profiling in SQL 16. And we made enhancements in Service Packs and SQL 17 to make it much more lightweight where you could turn it on almost all the time. If you catch Pedro Lopes on our team here at the event, he will talk your ear off about this technology because he was a big part of why we did this. And what they were able to find out is that we believe that we can turn it on by default and not incur significant performance overhead for your application so lightweight that you can just run it in production. So why is that even significant? Well, let's take this scenario. I'm just going to look at my task manager, my overall processor utilization on my machine. And I'm going to go to a directory here where I've got a workload. And this isn't, let me guess here, lightweight P, there we go. This particular query is one that just does a join between two tables in the wide world importers database. So I'm going to kick it off. Oops. And I'm going to go look over here, and I start seeing an increase in CPU utilization. It's like 40%, which isn't huge, but I didn't expect that from running this query. And so my problem is I want to go to a live server and see what's going on. Like, what is happening? Why is this query happening? And you can go to a live server today and see that a given select statement is running, and you can see it's consuming CPU. But what does the query plan look like? Well, you cannot see today by default. That you have to turn on diagnostics on your system. So I'm going to use Activity Monitor, go in here, and I'm going to see this query that's running, and I'm going to click on, if I get the right button. You can see it's running a parallel plan here. Whoops. I got to grab the right one. Oh, sorry. I'm just not highlighting it correctly. Let me go kick this off again. Let's see. Yeah. So now I see it live. Now, I just took a given query that I'm running in progress on a server, which would normally you'd have to wait, you'd have to kill this query or cancel it and run it again to see what's going on. I can see now live what's happening in this scenario. And I can see that I'm doing 2 scans against this table, which I did not expect. And if you dive into this query a little bit and see the text here, you can see I made a simple mistake in my join. I actually joined to the same table twice instead of joining to the other table. So imagine a scenario where you have an application or a developer that's made a mistake in something, put it in production, you see a high CPU thing kick on your server, and you want to know what's going on. You could see the query and may notice this mistake, but without being able to see the query plan, you may not know how to go debug and diagnose this. So without this capability today in SQL 16 and 17, you have to turn on your diagnostics after the fact. Now we're going to show this to you live by default. I kind of call this, I call this just-in-time query profiling. That's kind of my tag for it. So I could go into Activity Monitor right now, and I could just kill this thing and say, you know what? I'm going to kill you. And I'm going to let somebody else fix. I'm going to go back later and talk to my developer about fixing the problem. So that's just-in-time query profiling, allowing you to see diagnostics of SQL queries live on a system and go attack them immediately. Okay. So I didn't mention this earlier, Mitt, but you spent some time in this space on security and availability. So I'd like you to kind of spend a few slides talking about what we've done there for SQL Server.
Sure. Thanks, Bob. I think what's really interesting for me working on this project is the fact that you can take your existing application, change how you interact with it, and what Bob just showed you. You just made your application intelligent by switching to a new release. Got faster performance. Your performance tuning capabilities just went up a notch where you don't have to go back and say, hey, let's wait for the problem to happen again. Let's take that downtime again, and then probably I can tell you what the issue is. That doesn't really go down with management very well. At least my past experience tells me that. You don't get a lot of smiles, you don't get a lot of thank yous. But With this capability, you just change the game. And what I'm going to talk to you about right now takes us a step further. Every time we do a POC, the next question that comes up is always, hey, let's go talk about security. Go do the same POC now with enterprise-wide security and data governance. It just changes the POC because no, everyone's not an administrator. Everyone does not have access to all the data. Everyone cannot change all the data. And what you very quickly learn that the application is not supposed to modify the data, and that's not supposed to touch. The administrators are not supposed to read your email addresses, your credit card numbers, your social security numbers, your high-value data information. Anything that can compromise the company that you work for is not supposed to be read by an administrator. Then you'd get into this weird situation of the application encrypts a bunch of stuff using keys that it stores, but stores it in the database. And then when you query it, you're like, oh no, the performance is really bad because the database doesn't really know what's stored there. The application does. So you have to go through this cycle of moving data in the name of security, which is all very good. Like if I knew my bank was handing out my credit card numbers to someone, I would probably change banks. But in this scenario, your performance really takes a hit. So how do you actually change that? We introduced a feature called Always Encrypted, where the application held the keys to the data, but the data was stored in SQL Server. But that made you move all of your data around. And common scenarios like moving your database from your dev to test environment and changing your encryption keys, or even having the ability to change your data type, or doing large scans against that data. If you were not using deterministic encryption, it was a tough thing to do. Now with the introduction of enclaves, which is a hardware technology which allows you to do secure computing on the chipset itself, you can see the diagram of Always Encrypted has fundamentally changed. Your application is still holding the keys to encrypt your data, but the data is being encrypted on the server, on the chipset, where even if the SQL Server administrator wanted to, they would not be able to decrypt the data. And if you've used BitLocker in your Windows machines, think of this as the BitLocker for your database, not just for data that is at rest, but even for data that the hardware chip is encrypting only for parts that you want, not for the entire database. The next big thing is once you have stored secure data, you still want to audit it. You still want to know who accessed it. You still want to know who's actually touching that sensitive data. So we are introducing within the system catalogs, we're introducing new metadata columns, which allows you to tag data as high business impact or PII, or any other tags that you want, like GDPR compliance, HIPAA. You name the label, you can create it, you can tag your data. And what that allows you to do is it allows you to set up information access controls within your application, because you can just query a system catalog and find out how many HBI columns you have in your database. And using SQL Server Audit, you can actually start auditing everyone that's accessing HBI data. You don't have to set up some really long, complex script, which you have to know that, hey, you know what? CC241 actually means credit card numbers. You can just tag a column and say that, hey, this is HBI or credit card data, and now I want SQL Server Audit to track all columns that have credit card information. And the last thing that we're doing for this public release, which is CDP 2.0, is the certificate management across your clusters becomes very easy. What that allows you to do, it allows you to actually manage all of your certificates in your always-on availability group and failover clusters from a single interface, which is called Configuration Manager. Now, this is something that's very exciting to me. I never thought I would actually see SQL Server running on a Kubernetes cluster ever. With SQL Server 2017, we introduced the capability of running SQL Server on Linux. We support SQL Server on Linux and containers. What we're doing with the public preview release is we're actually adding the capability of availability groups, which is the HA and DR technology for SQL Server, to run on a Kubernetes cluster. And what that allows you to do is it allows you to create an environment where you have what you did today on your Windows or your existing Linux and bare metal and virtual machines, but inside a Kubernetes cluster. And why is that really important? Because now we're shipping a Kubernetes operator for availability groups. So you actually have tight integration between your clustering technology that you're using and SQL Server. And if a failure happens, let's say this is your setup, you're using 2 nodes for reporting and 1 node for writes. And if there's a failure, the application will automatically get redirected, and the pod that is actually your application, think of that as your application gateway, it will redirect the SQL Server write connections, and it will automatically now redirect your read connections to the primary replica, which is now your secondary replica once it comes back up. So you actually get load balancing across your SQL Server instances for your read workloads, and your write workload automatically gets redirected when you run in a Kubernetes cluster. The other thing that we have actually done is there's a number of availability group enhancements. We increased the number of replicas that we can support in a synchronous fashion. Now we support up to 5 synchronous replicas. What that means is you have the ability to use 1 primary and 4 synchronous secondary replicas. And one very cool thing that we did, which I personally find very exciting, is customers, when they were upgrading their applications, a lot of them came back and said we could not use the availability group listener for the simple fact that our application had hard-coded server names. So once a failover happens, I don't have the ability to change it. You have great technology, but I can't use it. So we are introducing the reverse concept of redirection. If you have a hard-coded application name, and if your availability group replica fails over, and your application now connects to what's the new secondary, it will automatically get redirected to the primary replica. So if you have an application that cannot leverage the listener, hey, we just made it really easy for you. So let's go find out what our data platform now really looks like. And Bob, you've been here 25 years. What did it look like 25 years ago?
So as a developer, I have a passion for development. I was a developer before I joined Microsoft. Actually, ironically, with Unix systems, it's kind of coming home for me to do things on Linux. But I think back to a long time ago, we worked on SQL Server, and it was pretty much Visual Basic, or C programs with DB library and ODBC. And so it was just a standard relational program client server you built. And I think today what we have now is very interesting, where we're headed towards what I call a modern development platform.
So why don't you tell us more about it?
Yeah, let me talk a little bit about it. So if you think about T-SQL as a language, which you've all learned and you've studied and you have skill sets on it, and you want to continue to use that language as a skill set, you want to lose that. I want to start using new languages other than just T-SQL. What I'd like to do is extend that. If you think about SQL Graph as a good example, is we're extending the T-SQL language to use graph data types built into the T-SQL by extending it with things like match predicates, node table definitions, things of that nature. And we've enhanced in SQL 19 that area of the product. If you think about, you're as a developer worried about space using Unicode data types, we now support UTF-8 built into the product so that you can reduce up to 50% storage space just by using UTF-8 where you didn't use that before. And then you see this diagram on the right, which is pretty interesting. If you think about this history, one thing I didn't really mention a bit to you is that I think about extending the T-SQL language. That journey started with something called extended stored procedures, kind of the bane of my existence in support back from many years ago. People writing DLLs, loading them inside SQL Server. And then we kind of added something called SQL CLR, which is pretty good. People use that today. Another assembly.NET language, again, also as a DLL or an assembly running inside the SQL Server process. But what we announced in SQL 16 was a new architecture and the ability to run R scripts in conjunction with SQL Server, but out of process. And then in 17, we added Python capabilities. And now we're proud to announce in SQL 19 the ability now to run Java code in the same architecture. So if you think about what we're trying to do now is extend the T-SQL language in a way for you to provide new solutions where T-SQL does not support that solution, but wrapping things like stored procedures on top of code that's going to run Python or Java, it provides new possibilities. Look at this diagram right here, just to understand and make sure you're clear about, if you're worried about the architecture of how we're running Java in SQL Server. We have something called a launchpad process. It's the same architecture we've used for SQL 16 and 17. And this launchpad process has the ability to take like a Java program or an R script or Python script and create a new process on the same computer as SQL Server, but directly communicating back as what we call a satellite process to the server to exchange data in a very fast and performant way. But this new architecture provides you process isolation, it provides you security, and most of all, governance. Resource Governor is tied into this technology. So you can control CPU, memory, and processing all of these Java programs. Let me show you this thing in action a little bit here, just so you have an idea what it looks like. Let's switch over to 6 right here. So I'm running Visual Studio Code with a piece of Java code. My good friend Nelly, who you saw on stage yesterday with Rohan, gave me this code. And it implements something called an n-gram. Anybody know what an n-gram is? N-gram experts? It's had to do with natural language processing of word classifications. So T-SQL does not have a function to do n-grams inside it. We're probably not going to build one, right? But Java provides that capability. So you can build a piece of Java code like this, and then turn around, and I'll show you in Azure Studio what it looks like. When you compile your Java classes using a Java compiler, you'll stick it in something called a class path, and now you're able to actually go execute a Java method in that program. And here's the really cool part. We've built a protocol for you to exchange data with SQL Server. So we are going to launch a process running this Java program that's going to do n-gram processing, this natural language processing. But you can take data inside your tables and exchange it with that program together in a very high performance way. It's how we've done this with R, and it's how we've done this with Python already. And so by simply enabling this functionality with spconfigure, which, by the way, does not require a restart now, thank you, developers, for putting that in, I can simply compile my Java classes. I can take this script, and I can execute it against my SQL Server, and it will come back with these results in a tabular format. Now think of the possibilities now. You then write a stored procedure on top of this with this Java code. You then implement that with your application, and now you're effectively just calling Java through T-SQL, any T-SQL. You're taking data in your database and exchanging data with it, and you're returning the results in the form of a row set, which could be put into another table or returned back to the application. It's pretty amazing technology. And again, in this particular case, if I was worried about my Java classes overtaking CPU processing or memory resources, you can just resource governor to control and throttle what that actually looks like. And here's the amazing compatibility story. You can take these Java classes, because it's Java, and because the SQL Server engine on Linux is the same, you can just move your Java classes to Linux and just run the same piece of code. It just works as is. That's built in now to SQL Server 2019. And that is the thought. And if you think, and I've talked a little bit about this, if you can switch back to 5, about the possibilities here, think about now Java providing you capabilities to do things that CLR could not provide, or you'd have to write an unsafe assembly to provide now. Credit card processing, any kind of type thing you can think of, you can now write that code as a server-side program in the database engine. Now, I mentioned before that my background was Unix before I joined Microsoft. So if you remember last year at this event, we announced SQL Server 2017 with SQL Server on Linux and containers. And we're continuing that journey. One of the big things we wanted to do was do something called feature parity. And that is, there's features outside of the database engine, like replication, DTC, and machine learning, that we wanted to make sure now work the same on SQL Server on Linux. The core database engine is identical, so things like column store I've always run as is, but things that are kind of on the edge of the engine, as I show here in this diagram, we wanted to make sure that stuff now works on SQL and Linux. We're also excited to tell you that we have this new thing called the Microsoft Container Registry, a new unified platform for us to publish our containers. So no matter if you go to Docker Hub or Red Hat Container Catalog or any other Docker or container site, you'll be redirected now to the Microsoft Container Registry. And in addition, we are also announcing with SQL 19 Preview a Red Hat container image so you can run SQL Server containers in environments like OpenShift. And then as Amit just told you, always on available group on Kubernetes is definitely an interesting pair of mine. Kubernetes to me is an amazing technology, and if you kind of missed it earlier in the diagram, Kubernetes is the power behind orchestrating all the big data cluster technologies that we're shipping. I have a session later today, shameless plug, this afternoon on SQL Server on Linux where we'll dive more into this technology and what we're actually providing. So Amit and I have been doing work at Microsoft for a long time, and our backgrounds are customer support and field engineering. So we're a big believer in listening to customers. And a lot of things that you see so far we've talked about are actually based on customer feedback. But here's some little goodies. We're always working on little nuggets of things in the engine that you've told us about through design change requests or feedback sites and so forth, or Connect, of what we should do. We want to enhance things in column store to make it more a first-class citizen for things like clone database or estimated compressions. But the last one's pretty interesting. It's something allows you to troubleshoot page scenarios through T-SQL. Can I show this? I got to show this. I didn't tell you I was going to do this, but
it wasn't part of the plan, so I'm going to see it for the first time as well.
I actually did this demo again this morning. So can you switch over to 6 right there real quick? Do we have any SQL heads in the audience? Do you know what a SQL head is?
I probably need to turn around because
okay. If you're a SQL head, you know this thing called DBCC page, right? You know DBCC page? You don't need it anymore. So I'm going to run this, if this works, show me pages.cmd. I'm going to run a workload. I'm going to go over here, and I'm going to look at my DMExec request, and I'm going to start seeing that I've got wait resources that are latches, like a latch wait on tempdb. Well, I see it's a database ID of tempdb, a file ID, and a page ID. Well, what the heck is page 10? You got to turn around and run dbcc page on that, right? No more. Here's a T-SQL script now with built-in functionality for you to dump out the page headers of those pages and know exactly what objects they belong to. So now, okay, yeah, go ahead. So the entire DBCC page header is available to you, and we actually provide functionality to crack out the page from that colon delimited resource there. So now you have this ability for any page you see that shows up like in a DMV, you can use built-in cross-apply functionality to go dump out details about that. And in this case, what's really important for tempdb is since I see the contentions on system tables, I know I've got the number of files right. I've got that figured out, which SQL Server can help you auto-configure. But now I know it's a system table contention, so it's something else. Maybe it's not temp table caching is really running this workload. So there's a little goodie. And I will tell you for sure, Amit, that we have more in store coming in this release. So
that's a nice surprise demo.
Absolutely. So I'm going to let Amit kind of close us out a little bit, talk a little bit about our tools that we're doing, and I'll give you a little feeling of what's happening past CTP 2.0. So Amit?
Sure. Thank you, Bob. What's really exciting to see from my career at Microsoft is there are things that I wished I had when I was doing support, things that I could do not pouring through text files and trying to write regex queries to actually figure out what the problem was when database sizes went from a few KBs to a few hundred gigabytes and terabytes. Going through all those DBCC page outputs became really tough. And that is the genesis of what you see on the slide. Every time we actually work with a customer comes to us and tells us that running SQL Server in a massive corporation is tough, and these are the challenges that we have. We always make it a priority to hear the feedback and see what we can do in the current release of the product and in the next release of the product. And what you see here is all driven by customer feedback. We introduced something called the DBCC clone database, which essentially allows you to do one thing. It allows you to take the clone of the database with the schema, the statistics, the design of your indexes, and all the other components, and take it to another environment just to inspect and troubleshoot, or even for developers to look through the schema of what's running in production. What it did not have was things which we are seeing a very high adoption of, column store statistics. Now column store stats are part of DBCC clone database. So if you take a clone and if you have a column store heavy functionality, that can be ported into clone database. Another thing that we heard loud and clear from customers was, hey, you said use column store indexes, it reduces the size of my data, leads to greater performance, but by how much? We had this compression space savings stored procedure that allowed you to figure out how much of space savings would you get by using compression on your row store. But we did not have the capability, and you were always in 2 minds. Should I try it? Should I not try it? This is a pretty large database. I have to create another one in test. But let me just run a stored procedure that estimates the amount of compression I have, and that will actually tell me what kind of space savings I'd get. So you can actually take our existing stored procedure to estimate space savings and use that to figure out how much space savings you'd have with column store compression. And what Bob just showed you, the page resource, that was, again, pretty cool. So we have all of this capability, and you will see throughout the release, CTP 2.0 is just the first step of the public preview. And what you saw till now is just what is in CTP 2.0.
Yeah, we have more of this coming.
So this is not the release. Before I get asked the question, is this the feature list for SQL Server 2019? No, it's not. it is what you have today that you're downloading. You'll have a lot more whenever we release public CTPs. We will update our what's new, and you will see more features lighting up. And I can tell you from every big event that you come to where SQL Server is a topic, you will go back thinking, oh, that's new. And that's pretty cool. And that's a guarantee that you have that the SQL Server team is going to continue giving you capabilities that's going to get added to SQL Server 2019. And what you see from here is not going to be a repeat in the next session that you come to.
Everything we showed you today, you can do right now. You could walk out of the session, download SQL 19, and try everything we just showed you.
So this is all about Azure Data Studio. So you saw me when I was doing my demo, we were actually using Azure Data Studio. This is a new tool that we shipped, and I'll take a quick moment to talk about the name. As you see, it's Azure Data Studio. It does not say SQL Server Data Studio. And the reason for that is the Azure Data Family covers a lot of products and services and not just SQL Server. This is the start of a journey which allows us to combine the experience for DevOps under one single umbrella, whether you're running Azure SQL Database, whether you're running Data Warehouse, whether you're running OSS technologies under the Azure Data Family. This is the journey that starts combining all of that into a single umbrella. And what it also does is it gives you this capability of running this tool on other operating systems. You can now install this on a Mac, you can install this on a Linux-based operating system, and obviously you can install this in Windows. With SQL Server 2019, we also released our updated Management Studio. So what you saw during our demos today, we're actually using the preview version of the Management Studio, which is also available for download. And what is very interesting for me is the capability that you need for managing this cluster. We're giving you this great new feature of big data clusters, but that would not be complete if you didn't have a management interface for it. Even though everything is managed under a single Kubernetes cluster, everything is provisioned, you still need the capability to look at what your resource usage is, need to expand your cluster size, shrink your cluster size. All of that management capability comes into Azure Data Studio. The other thing that we are not showing in this demo, but there are other sessions today. There's a session from our colleague Vicky Harp, who leads our tools, and she's responsible for Azure Data Studio. She'll be talking through the capability of notebooks. Yes, you heard that correctly. Notebooks inside Azure Data Studio, which actually can work with SQL Server. So you actually have the ability for your data scientists to start leveraging this and run notebooks to do their data science work. Now, since this is a roadmap session, I think it would not be complete if we didn't talk about a roadmap.
Like, what else are we doing, right?
So what you saw till now, as Bob said, it's all in the public preview today. You can download it, rerun the exact same demos that we did. But this is what's coming. This is what's on our roadmap. And one of the things that I talked about was devices that I'm wearing, devices that are in my pocket, devices that are in your home. All of these are producing data. And this data explosion needs you to manage data, not just by moving everything to a single data store, whether it's a private or a public cloud. If you had to move this petabyte of data that gets generated over a period of 1 year into your data warehouse, you're just going to be doing data movement. So you need the ability for your edge, which is either a gateway or a smaller device, and edge is a pretty overloaded term. If you wanted to actually process that data and filter that data, but still score at the edge and train in your data centers or on the cloud, we will give you that capability. And that's something that's a big investment area for us. SQL Server today runs on various different platforms that you know, and having the ability to score in a central place and ingest your data, that's a scenario that's perfectly valid today. But we're constantly seeing customers come back to us and say that, hey, I need to score at the edge but train in the cloud. And that is also another decentralized machine learning scenario that we are working on. Obviously, the features that we talked about, the data virtualization and the big data clusters, we'd continue to enhance that. You'll see new connectors. You'll see new experiences light up in future CTP releases. SQL Server is a pretty good database from a performance, scale, availability, and security perspective. You'll see more and more investments in that area as we move forward. And we will continue to enhance those capabilities. And every time we do a CTP release, you'll be able to go through what the new changes are. And given what I know, some of those are pretty exciting. And me having worked on the other side, being a consultant and a SQL Server developer, it actually makes it very, very interesting to see some of these changes that we're working on. And I'm like, man, I just wish I was in that job now. We would also continue to leverage hardware innovation. My colleague Arjunas is going to have a session later this week, which is going to talk about how we leverage persistent memory. And that's going to show you more about the performance and scale improvements that we are making in SQL Server with persistent memory. The cool thing that I really love about SQL Server is this ability for you to create this unified data hub that we talked about. But it just doesn't end there. With all of these features that Bob talked to you about, intelligent query processing and this ability for SQL Server to make it faster, stronger, that's the term that you hear in sports, right? So the database is actually becoming faster and stronger. And you can actually leverage all of those capabilities when you virtualize your data sources. Now capability that did not exist in another database and that you wanted to leverage, like in database analytics. Like if you wanted to leverage SQL Server machine learning services on top of data that does not reside in a database that has ML capabilities, you just unlock that skill set. It's like a game. You just unlocked an achievement. You can now make your data smarter even though it's not residing in SQL Server. And those experiences will get better, not just in virtual machines or in bare metal. We will actually make those possible in containers. Think of the ability of training your models and then scoring through containers in your big data clusters. Or even SQL Server running on Linux, you can actually operationalize everything in a container and spawn up the containers when you need it, get rid of them once the job is done. So you actually created a serverless scenario where you're spawning up compute when you need it, and the compute goes away when you don't.
You know, let me just add that people have asked me at this conference, actually, what skill set should I be adding, things I should be looking at from a trend with SQL Server. And if I had to pick one thing, I mean, ML, and big data, that's really the thing that we've announced that's very exciting. It would be containers. Containers is a technology, kind of a platform and infrastructure that you're going to see us really leverage going forward.
And this experience is not just because we want to ship something which is pretty great. It actually gets you up and running really, really quick. One single command, and we have a session towards the afternoon where we talk about what the big data cluster can do. And you'll see throughout the session that they're actually setting up very complex environments where you have got job scheduling, you've got machine learning services, you've got Apache Spark, you've got SQL, you've got HDFS. All of that is being set up using a single line of code, using containers. That's pretty powerful. You're actually deploying hundreds of containers through one orchestration engine using a single line of code. So that actually simplifies administration to a great degree and also adds capability to do more. So this is what we have throughout the week. So today at 4 p.m., my colleague Travis Wright is going to talk about the future of SQL Server and big data and what sort of scenarios you can build on top of what we're shipping. And that's a deep dive session. He's going to show you some pretty cool demos on spawning up hundreds of nodes doing SQL and Spark. Vicky Harper is going to talk about cross-platform tooling for SQL Server. This is where we talk about our tooling strategy, what we have today, and where we're going, what the journey looks like. And Bob is going to talk about what's new in SQL Server on Linux and containers today.
Today, we're doing that today, yeah.
So all of these are new capabilities that we're adding. If anyone had talked to me about this 5 years ago when I was at Microsoft, I'd be like, no, we're not doing that. That's not even on a roadmap. But this is all real today. You can download it. You can play around with it. And if you have any feedback, as I said, please reach, as Bob said earlier, please reach out to us. We're more than happy to listen to the feedback. And you saw that we actually dedicated a slide in here talking about customer feedback and enhancements that we're putting in the product. So go ahead and download the app. I would say evaluate the session. And download SQL Server. Tell us what you think about it. Give us feedback. The links are up there, the short links. Join the early adoption program. The SQL Server Big Data Cluster is still under a gated public preview, so you'll have to sign up for it. And then this is the page for what's new in CDP 2.0, the key being what's new in CDP 2.0.
So hey guys, thank you so much for your time today. We're going to end the session now, but we're going to stay here afterwards. We've got about 5 minutes left. We'll take your questions, and we'll stay afterwards. Thank you for coming today. We appreciate it.
Thank you very much.
So come up to the mic if you have a question right here, and everybody can hear as everyone else is leaving. So just come up to the mic and ask your question, and we'll be happy to address it.
So continuing my...
Can you speak up a little bit, please, so we can hear?
Continuing my question at the start of the session is how exactly you scale out from performance point of view on big cluster. As I said, today I can use linked servers. What kind of technology is actually used? Or because if you, for instance, query a join between, let's say, Oracle table and SQL Server table today, of course, it brings all the data back to your SQL Server. So actually, what are you using differently?
So that's a good question. So the question is, how do you actually increase performance over linked servers, which you have today, which can already query external data sources or relational data sources? So there are 3 things that we're doing. The first thing is we're going to support predicate pushdown in our operators. So we've actually enhanced Polybase to support predicate pushdown. So queries that you're writing will not fetch all the data, but it actually use the engine on the other side to push down the filters that you provide, so it does not get all the data. The second thing that we're doing is we have enhanced the capability of our scale-out groups. So now the query can get partitioned and scaled out across multiple compute nodes. What I showed you in my demo was just one SQL Server instance, but you can use that as a master instance and have scale-out worker instances.
So exactly this scenario masters. So actually you have, when you're pushing in a scale-out scenario, you have SQL Server engines running the queries for you on each node?
Yes, you have a SQL Server query engine which will scale out. And if you're doing it on our HDFS platform, so then you have Spark running on it or SQL running on it. They're tightly coupled in each of the containers. And depending on which engine you use, you can scale out. And the third thing that we're doing is to make subsequent queries faster, we'll give you the ability to just create a data mart on top of it backed by column store indexes. So subsequent queries would also be faster.
Basically.
In memory. Mm-hmm. And that also leverages improvements that we've done in the buffer pool. When you do these scale-out queries, the buffer pools also act as caches for you on these scale-out nodes.
Thank you.
Thank you very much.
Thank you. Next question.
You mentioned you have SQL Server Manager Studio 18 coming out preview with the 2019 preview.
SQL Server 19 preview.
So
we've already announced it's already there today.
Yeah, with Azure Data Studio, will it be able to do the same exact things that Manager Studio for 2019 able to do? Will the exact same functionality be available?
So the question is with the same functionality for Azure Data Studio and Management Studio. So there's a difference in what you would use for what, and we'll have a detailed blog post from Vicky outlining that. So if you're using SQL Server Management Studio today to manage your SQL Server instances, then the preview version of Management Studio is what you would use. But if you're using the big data cluster and you want to build on top of it, and you want to have a notebook experience, you want to have this experience of external tables, data virtualization, do big data with SQL Server, all of those new experiences that we're building, then it would be Azure Data Studio for you. So there are 2 different tools for 2 different purposes.
One quick answer too, Management Studio is going to remain on Windows only. So if you need cross-platform, like you need Mac, you need to run on a Mac or a Linux, you need to use Azure Data Studio.
But it will still have the granular functionality that Management Studio would have, right? Or will it be features that Azure wouldn't have?
So the Azure Data Studio is a new tool, so we'll keep adding experiences to it. But the parity of what you have on the Management Studio today, from a granularity-wise, is not the same with what you have in Azure Data Studio. So as I said, for administration, Management Studio is still your tool set for production scenarios.
Thank you.
Yeah. Always on groups. Right now we have read-only secondaries. When are we going to have writes to the multiple nodes within our always on groups?
So the question is when would we have writes within the same availability group? So for this release of what you have in the CDP, there is no write capability. But from a scale-out perspective, what we're doing, the ability for SQL Server to scale its writes is going to change the way you know it today. And what that does for you is the business scenario is how can SQL Server, without having to go add more and more hardware, how can it actually scale? And you'll see over the next few public CDP announcements, we'll talk more about how we're increasing the scale of SQL Server, where you would not have to do cross-replication between multiple SQL Server nodes sitting in your cluster.
Thank you.
Hi, back.
Sorry, can you?
I was just going to ask about the time frame for those CTPs next year.
For those next CTPs, I'd say stay tuned to our blog.
Yeah, we're not publishing any dates on future CTPs or anything right now.
So back to the previous question, with accessing the Oracle data, are there certain data types that are not supported right now, or is it just any Oracle data types?
So right now, blobs are not supported, so CLOB and CLOB data. Today, in this public CDP, if you wanted to try that, the visualization would tell you that the data type is not supported. But most of the common data types which are not binary lob data is supported.
Thank you. Please come to the mic if you have a question. Any of the mics.
Wondering why isn't there any basic percentile or median function that can work with average, min, max?
So the question
in T-SQL, in like a T-SQL function.
The question is, do we have a percentile? We have a percentile function. I would love to know what capabilities we're not able to solve offline.
We have some functionality there. Are we not solving something? Or?
Percentile is a window function. So,
okay.
So it does not adhere to the grouping, basic grouping.
Okay, so that's good feedback. This is just a CDP release. And
that's when you should email us on. We'd like to know more about that.
We'd love to.
Bob Ward or Amit Ban at Microsoft.com. Send us a note on the details, and we'll talk to you about that one.
Okay.
Thank you.
Great. Thank you.
Yes.
Hi. With the old version of SQL, we had UDC, but with new releases, we don't have it. Is there a plan to bring back UDC?
Sorry, what?
UDC.
UDC?
Yeah, register servers across the board, centralized management servers.
Utility control point stuff.
Oh, yeah. Okay. So got it. So
utility control. He's utility control point. UCP.
Utility control point. So I don't know if you noticed, and short period of time we were kind of going through the screens pretty quick, but you still have the ability in both in Management Studio and Azure Data Studio to register servers, and you can create custom dashboards on top of it.
Okay.
So that capability, while it's not the same feature, the scenario would still remain, and you would continue to see enhancements on top of that as we go through our tooling journey.
But to be clear, we don't have any plans right now to make any enhancements to that specific functionality that you used before. It still works, but we don't have any plans to make enhancements on it.
Okay. All right.
So that's not getting any investment for this release.
That's correct.
Okay. Thank you.
Yeah, you bet. Next question. We'll just take a few more, and then we'll go outside and just answer anything privately. We want to let the next presenter come up here. So.
Two quick clarifications. What version of Oracle do you support? Is it 12C or 18C or cloud ones, or do you support all of them?
I just go double check versions.
So we'll have to go back and double check on the versions if you send us.
For the external table functionality? I think we've got that documented.
Yeah, we've got that documented. I just don't remember.
I don't remember off the top of my head. If you look at our documentation, they state that. So.
Gotcha. And the second question, you mentioned one of your colleagues doing the session on SQL Server with SCM. What was the person's name? I want to be able to make sure I have that.
For System Center?
Storage class memory. Persistent memory.
Oh, persistent memory.
Argenis
Fernandez.
How do you spell that?
ARGENIS.
Yeah, it's called like a SQL Server and hardware modernization. That's kind of like the title. So yeah, thank you. Yeah, there you go. That's it. Thank you.
Hi, question on SQL on big data, right? So one of the big win for Apache Hadoop or big data technology was data localization. Mm-hmm. So in terms of deploying SQL on big data clusters, do we have the same deployment strategy or like something different?
So the question is, what's the data localization
on SQL
on SQL Server big data cluster? So if you notice in my architecture diagram, every HDFS storage node will have a SQL and a Spark tightly integrated. So in big data, you have the ability to scale out your storage, but not your compute. Compute sits somewhere else. We're actually bringing that together so you have compute closer to your data. And if you're using storage outside, like HDFS storage outside, like Cloudera or Hortonworks, you will still have the ability to scale out your compute, and they would do a scale-out query against the SQL Server instance or the cluster that you've created, and that distributed query would query your HDFS data sources. If it's external, you only get the compute scale out. If you're using our HDFS layer, which is our HDFS storage, which is shipping with SQL Server, then you'll have the ability to tightly couple, not just have data localization, but compute and data together, which would increase your performance. Does that help answer?
Yeah, I was more, my question was more in terms of performance, like how it's gonna,
So
well.
obviously, if you have compute and data closer together,
Right.
perf is going to be really great. If you cache it, it's going to be even better. Direct queries are obviously going to be slowest. So if you're running a ad hoc Spark job over billions of rows, that's going to be slower than if you run it on our HDFS layer. And this second scenario is going to be slower than if you're actually caching it in a data mart. So we have all the capability.
Okay.
It's a choice and business feasibility that you'd have to decide on.
Let's take any random questions here down here, because we're going to let the next folks come on stage.
Thank you.